Last time when we talked about compound events, we talked about how the word and means to multiply in probability. This time we'll be talking more about the word or, and it turns out that the word or means that you will add. First, I wanted to show you these Venn diagrams. The first one shows you what it would look like for events A and B to happen. That's the overlap, right? Now, when we're talking about A or B happening, you have to consider that that's A or B or both. That's just implied. So if they ask you if you're in stats or if you're a senior, that would include all the stats students and all the senior students and all the stats kids who are seniors. Mutually exclusive events are events that cannot occur together. They're disjoint. Their Venn diagram isn't even connected. There is no overlap. And that's the simple case in probability. When we're finding the probability of A or B for mutually exclusive events, that or simply means to add those two probabilities together. Let's first look at why each of these are mutually exclusive. Can a card be both a heart and a diamond? No, it's going to be one or the other. Can it be Monday and Thursday? No, it's going to be one or the other. And if I were rolling a die, could I roll an even number and a 3? Not on just one roll. So each of those is considered mutually exclusive. Again, the probability is very simple then. All we do is we take the probability of getting a heart, which would be 13 hearts out of 52, and the probability of getting a diamond, also 13 out of 52, and the word or instructs us to add those together. And you'll notice that the answer is 1/2 because half of the deck is hearts and diamonds. So your probability of getting a heart or a diamond or red card would be 1 in 2. The probability that you choose a random day of the week and it's a Monday, 1 out of 7. That it's a Thursday, 1 out of 7. Can't be both, so or simply means to add those together. Probability of an even number on a roll, there are 3 even numbers. Probability of getting a 3, there's only 1 3. So pretty simple when we're talking about mutually exclusive events, events that don't overlap. They cannot happen together. Non-mutually exclusive events do make the process just a little bit harder because if you think about this, if we counted everything in this circle and we added on everything in this circle, do you see how we would have counted the overlap ones both times? We would have counted these guys twice. And we don't want that overcounting. So this little formula is going to take care of that again. Or still means to add. We're going to take the probability of A plus the probability of B, but then since we would have counted a few things twice, we will subtract off the ones that got counted twice. So then they only get counted once. Each of these are not mutually exclusive because can you have a card that is a heart and a king? Yeah, the King of Hearts. Could it be Monday and be October? Absolutely. Could you have an even number and have that number be less than 3? The number 2 would work. So just one extra step here. The probability of getting a heart, there are 13 hearts in the deck. The probability of getting a king, there are 4 kings in the deck. The word or means to add, and then if we just always think, have we counted anything twice? We counted the King of Hearts, there's only one of those, twice. And so if we subtract one off, then it will only be counted once. The probability you pick a random day in the year and it's a Monday. I'm going to estimate here, there are 52 weeks in a year, so I'm going to say that there are 52 Mondays in a year. I'll go with 365. Or means to add. Days in October, there are 31 days in October. And if we use this year as our example, there were 4 Mondays that were in October. So that means we counted those 4 Mondays in both groups. And finally, rolling an even number or a number that's less than 3. Probability of rolling an even or means to add. There are 2 numbers that are less than 3, and then the overlap was the number 2 because it's even and it's less than 3, so there's just one of those that got counted twice. And that's how that works for non-mutually exclusive events. Here's an election example. A simple random sample of 100 registered voters were asked which party they identified with and whether they had planned to vote in the upcoming election. If a person from the sample is selected, find the probability that they're either Republican or Democrat. And I would say that those are mutually exclusive. You wouldn't be both. So the probability of being Republican, we can see that they surveyed 35 Republicans and 25 Democrats. The word or means to add. And since there's no overlap, there's nothing to subtract off. The probability of being Republican or not planning to vote, or both. So we would take the probability of being Republican the probability of not planning to vote, or means to add, but then we've counted some people twice. We've counted the Republicans who don't plan to vote twice. So we counted these people twice, so we will subtract them off. Now I just used the formula to calculate that, but we can actually just look at the chart of the 100 people and their responses, and we can take all the people who don't plan to vote and all the people who are Republicans. And if we just added all those together, we would have total Republicans or don't plan to vote people, which would be 50. And so that's just another way that we could have calculated that same probability, is just by adding up the numbers that apply in the chart. You are absolutely allowed to just use the numbers in the chart, but I'm just going to keep practicing the formula. Plan to vote or not Democrat. Those would not be mutually exclusive. There is some overlap there. So how many plan to vote? That's 70. Or means to add. How many not Democrats are there? Well, if there's 25 Democrats, there would be 75 not Democrats. And then we would want to subtract anybody who plans to vote and is not Democrat, because those got counted twice. Plans to vote and is not a Democrat would be those 55 people. And if we were looking at that chart, we were counting all the people who planned to vote and all the people who were not Republicans. So the only people we didn't count were these 10 that were Democrat and didn't plan to vote. So that's why we got that 90 out of 100, because the only people that didn't apply were those 10. This next one's a little different. It's using that notation of given neither. So plan to vote given that they don't identify with either party. Remember that the thing that you're given is going to affect our denominator, because we have narrowed it down to only the neithers. So how many people identify as neither? That's these 40 people. So given that we're choosing from that pool of 40 people, what is the probability we find someone who plans to vote? That would be 35 of them out of 40. And here's one more, or plan to vote or don't plan to vote. How many plan to vote? That's 70. How many don't plan to vote? That's 30. Or means to add. You couldn't plan to vote and not plan to vote, so there's no overlap. Those are mutually exclusive. And this just tells us that everyone has a plan. Either they're voting or they're not. That makes up the entire sample space. Here's a cute little cartoon. I think we should be exclusive. Mutually exclusive. Ha ha!